Good morning, students. Today we are going to discuss the concept indexes in DBMS. I think you already heard the term indexes. When it comes to a general term, indexes is used to search a particular item in a very fast manner. So this is the purpose we are using indexes. Um, there is a real-time example you may use in a day-to-day life for indexes. So you have a textbook, so I want to give you a topic and search the topic in your textbook means. So first what you do, you just go to that particular content or index page which is in the first page of the book, and you can note that with the topic which is available in the particular page number. So you note it down and then you go to the page directly. So you are not going to search the book from the first page to till the topic what I said in the particular page. So this is the way you are going to do the smart work. So the page number is enough to search to reach the particular topic. You may get the page number from the index page. So this is the concept behind indexes. You are going to use the same concept in database management system. So in DBMS you have a lot of records in that DBMS. So if you want to search a particular student detail or an employer detail, you may get it quickly with the help of indexes. So how we are going to get the record quickly with the help of indexes. So what are the features behind indexes? So this is the thing we are going to discuss today in this concept. So first we start with the introduction of indexes. Indexes provide quick access to and uniquely identify the row of a table. So when it comes to a database, we have storing the information in a row. So particular student detail or a particular employee detail, or it may be it should be available in rows of the table. So we are trying to speed up the row access in a table. Oracle uses the concept of indexes to do this speed up process. Actually, index is an optional structure associated to tables and clusters that allows a faster execution of the SQL commands. So this is the example that this is the way I'm going to use index in DBMS. So note the given picture in this slide. So we have a table named as employee table with a lot of columns. So they are listed as employee ID and a name and minimum and maximum, so whatever it may be ID. So we are listed few columns here. So the table can have any number of columns. This is not the issue. Now we are having a index table in a separate area. So index is a separate table. So from this diagram, so you may note that index is a separate table. It have a indexes based on a particular column in a employee table. So it take any column in a table, but it should depend on one particular column to retrieve the records in a very fast manner in the given table. So index, this is the index representation. Next, indexes features are listed here. So what is the thing which is possible with the help of indexes? So indexes are not appropriate for all tables. So this is the main features of indexes. So when it should be applied. So the columns that have many rows with the null values, the columns containing many identical values, and tables with a small number of rows is not suitable for creating indexes. So we are depend on one particular column in a table. So the column can have this such restrictions. So the next feature about indexes is it is suitable to select a suitable candidate to create index. So that is the presence of data in a column and the columns that are used as primary keys. So next, those columns used as foreign keys. So this is the thing. Next we have to concentrate on index when we are trying to create an index on a particular table. So the features are continued here. So a table can contain any number of indexes. So there is no such restriction to create an index. So this is the number of index you should create. So this is not possible. So that much of limitation is not here. So you can create any number of indexes for a table. So the only thing you need more effort to manage and update the particular index. So creating index is not only the part or the only job we are going to do. So later on you should give effort to manage and updating the particular index. So next, when you are trying to do update or insert operation, so additionally the database also has to update all the indexes. So this is important. So first we create a table, index for a particular table which have a limited number of rows. Later on you have going to add the records in a particular table. So then the index will also be updated. So whatever the changes you are going to made it in a table, it should be reflected in index table too. So an index can be created using the content of one or more columns of the database. So first we discussed, depending on one particular column, the index is going to be created. So now this is one more add-on about indexes. You can create indexes for combining one or more columns. So this is a feature named as composite index. So, but the thing you have to keep it in mind, the most important column should come first. Okay. Then you have one more point about indexes, that is the index can be unique or non-unique. When you are using a primary key, when a primary key is created in a particular table, Oracle creates it as a unique index. So the next thing about indexes, SQL commands used to query or update the tables and it do not change the existence of an index. So you may do something in a particular table. So that value change or the particular informations are updated, it will never affect the index. So index is a separate part. It's only the purpose of using indexes. You are going to fetch the record in a very quick manner. So it does not affect. It will get affected with the help of, when at the time of updating or using any query in a particular table. So indexes can be created or deleted without affecting the data which is in a particular table. So it occupies additional disk space for storing the indexes in a memory. So this is the only noted drawback I think in about indexes. When storage is limited and storage is not enough, in the sense indexes is again a difficult to manage in a memory space. So it actually we are going is table in one location and we are trying to store the table, that is a index in another area. So it added the space is needed for that particular table. All the changes made to the table automatically update the indexes that were created. So this is the features of indexes. So next, the point about indexes is, so indexes can be created during the design process of the table structure. So at the time of using the primary key constraint, so we can able to create an index too. So when the table has existing data, so already I created the table but I forgot to create an index. So we can add the indexes for that particular table too. Whenever a new row is inserted, the indexes are updated but the thing is it require more processing time. So when you are try to create an index for already created table, so this is the thing. So next, creating an index is possible at the time of creating a table, and filling it with the data requires extra space for the organization of the indexes. So this is the possibilities of possibilities are the things which happen at the time of creating indexes. So we should concentrate on how to create a indexes, or where, for which table I am going to create index. So if you are decided at the beginning of the table creation, you can do at the time only at the time. And if you want to create a index for already existing create a new table, you can also do it. So but there is a limitation that you are not able to create index for this particular columns, but the columns can have lobs data type, long and a long raw data type, so it cannot be indexed. So this is the thing which you may note it. So indexes have this particular data type, in the sense you never create the indexes. So how you are going to create an index, and what are the steps or the possibilities you can create index. So creating index with the constraints is possible. Next, creating index with the create index command is possible, and creating a function based index, this is also possible. Next, creating an index using a key compression method, so this is also possible. So how now we are going to discuss how we are going to do the same when it comes to query. So this is the first thing. When creating a constraint using a unique or primary key, Oracle automatically allocates an index if the constraint is enabled. So no other command is necessary for creating the index at the time of creating indexes with a constraint. So you can do simply. So this is the thing which is a special feature of this particular syntax. So through primary key or unique key constraint, we can able to create an index. So there are two options for doing this, that is enable or unenable and using index option. So this is the syntax for creating an index with a constraint. Create a table name, and the columns are listed here with the data type. Note that in the second line of the query, enable and using index is represented here. I am going to create the index at the time of creating the primary key. So this is the way I am going to create an index. So next I am going to create an index with a create index command. It is the responsibility of us to creating a simple index using a unique or composite indexes using more than one column. So listen the syntax, that is create and a unique, it's an optional one, index name on the table name, and the columns are listed here. If you are going to give more than one column, so this is also possible, either in ascending order or descending order, so you can able to shortlist that. So next the attributes are related to that particular index creation as cluster, initial transaction, maximum transaction, table space, storage, and PCT free, no short, and recoverable and unrecoverable are the parameters or the arguments associated to that syntax. So you can define that particular arguments or parameters to restrict that, or the give a more detailed note about indexes. So how many transactions are allowed, or the maximum transaction that is, and what is the initial transaction, and the storage space limited to that, how much storage space is free. So everything you can able to give as an input at the time of creating indexes in this syntax. So creating indexes with the create index command, arguments and the features are listed here. So the cluster, and the table space and PCT free. So table space is again represent the memory area what we are going to use for our program. So next, PCT free, already we know that in the previous chapters, that is PCT free represents the space that should be left free and unused by the indexes. So cluster, if you want to creating a cluster, so it should be available. So based on the features of that particular index, it should be a part of one cluster. Okay, it would have a similar functionality or be a similar function, similar purpose, so we can associate it into one single cluster. So next, the arguments are initial transaction and the maximum transaction. So it indicates the initial value and the maximum space allocated for the transaction of the data blocks in the indexed segment. So again, these are the arguments you may use. So it is not compulsory to represent all the arguments associated to that syntax. You can use it at minimum. So when it is not needed, so you can just ignore it and give the mandatory one. So this should be enough. So next we are going to see the practical example how we are going to create an index. So this is the first step when I'm trying to connect to that particular DBMS. That is with the help of the connect command I'm going to connect demo, and the password is also demo. I'm connected successfully. So next I'm going to use the next slide after connection. So you may able to create a, or you may able to find out the table when it is needed. You may find out the you may create a table, otherwise you may find the table which is listed in that particular username, login and password. So you can retrieve it and then you can create a index for the existing table too. We already discussed we can create a index for new table or the existing table. So I'm going to search that list of table which is already in that username. That is, this is the command for that, select a table underscore name from user underscore tables. So here I have a list of tables which is already created and stored in this system. So note that table names are listed here. Customer is a table, department is a table. So the entire table names are listed here. So note that I'm going to get the content of the one particular table, that is the department table. So department ID and the name and the location ID, this is the attributes available in a particular table. So I'm going to create an index for the column name. So this is the second column in that particular table. I'm going to create it index for it. So create index name and create index name on the table name. So within that bracket I'm going to represent the column name which is in the table. So this is the key ID. I'm going to make use of it from the particular table for index. So used on this key only, I'm going to fetch the records within a particular table. So after creating the index, a new query to the table will not show a physical order. So the new index will be updated. We cannot create an index that uses only one column if it was already used by another index. So this is the thing you may note. This is another important feature of index. So we can create composite index that includes column that was already used by another index. But there is a restriction. You can create an index for one single column, means you cannot create one more index for using the same one column. So when it comes to composite index, this is not a matter. So you may do, but this is not applicable for creating a single column index. So this is the example which shows what we discussed now. Create index name on table. Within that bracket I am going to mention the column name. Note that this shows error because we already created the index for this particular column separately. So I cannot duplicate the indexes for one particular column. So the next index is create index. Index name on department. I am going to represent the column, that is two column. I am going to create a composite index, that is name comma location id is the columns I am going to represent here. Now the index is created. So think that name is, if it is name is a separate column for creating an index, you can do it one time only. When it comes to composite index, you can do it, there is no such restriction for this. So this is about the creation of indexes, either it is a single column index or composite column index. So next thing, existence of indexes does not change the execution of other SQL commands. So now I'm going to show you one more example. I'm going to connect with the username, password, Scott and Tiger. It is connected successfully. So this is the example. Create index. Index name is ind underscore e name. On the table name, within that bracket I'm going to represent the column name. So table space and storage, next PCT increase and PCT free, everything is represented here. Index is created successfully. So creating a function based index. So function based index is improve the queries that they use a value returned by a function or expression, since they store this value by expression or function of the index itself. So function always returns something to us. We are going to make use of the value which is returned by that particular function. So using this particular value, I am going to create an index. So this is the advantage. It have the ability to include sorts based on keys containing words with accents. So this is a, suppose I am going to get the value of particular column. So the example given here is, so employee name is employee name is one of the columns in the employee table. So you are going to get the employee name, either it should be converted into uppercase. Later on I am going to use it as a value of particular index. So this is about, so output of one particular function is going to be used as a value for indexes. So create index, the index name is named as x1 on, and the table name within that bracket I am going to mention this is uppercase employee name. So next, names in lowercase are combining lowercase and uppercase. The following select command returns the data from all the entries that includes a one particular name, Smith. So this is the command for that. Select star from new MP2, where upper within the bracket a name. This is the column name I am going to use here. So the name should be Smith. So this is about the another example for creating a function based index. So next, one more index, function based index is available here. I am going to create an index based on the German language. It does not apply to the examples table we are using, but this is the syntax which will be used for this. So create index. The index name is represented as NLS index on table. Within that I am going to represent the function name, and name and NLS sort is equal to German. So the creating an index using key compression. So creating an index is possible. We discussed a lot of method. The purpose of index is for quick access, but when we are using a one particular column have lot of duplicate values, so it is again difficult to us. So we are trying to eliminate the duplicated values of a key column. That is, key compression breaks the key into two parts. So one part is a prefix and another part is a suffix. So we are going to use the prefix shared by all the entries of the index block. the the name represented in one particular area can have some common name, like that Maria Angel and Maria Sebastian. So whatever it may be, the first name should be common in all the names. So we are trying to eliminate the common names which is in a particular column, and then we are make it the search little bit faster. So to avoid duplication, we are doing it, definitely we are able to do that particular process. So the index creates the prefix Maria, which is shared by all the 1000 records. So this is the thing, we are going to compress it and we are going to focus on the part of the key which is a unique one. So then we can do this. So saving space and improving performance is possible with the help of index, creating index using key compression. So to create and compressed index, we are using the we are adding the compress class. Create index name, within the bracket I am going to mention the column name, and a compress, and the value 1 is represented for doing the compression steps. So the key compression can be enabled or disabled. There is the features for that. The key compression is disabled with the alter index command with the keyword no compress class. So you are going to alter the index with no compress class. So changing an index. So restricted to modifying the transaction and storage parameters is possible. So it is not possible to change the columns of the index. So when you are trying to change the column, the only thing you can do, you must delete the column, or so you must delete the index or recreating the index with a new definition. So alter index command. So this is the way I am going to use the alter index command. So alter index name, and the initial transaction, maximum transaction, and the storage value is represented here. So this is the way I am going to make changes in the attributes associated with the index. So recreating an index. So how we are going to recreate the index? So recreating in the index is possible with the help of the command alter index command. It is the equivalent of deleting or reconstructing the index with the advantage of reorganizing the fragmentation of a block and providing better performance. Alter index name and rebuild is mentioned here. So the rebuild option specified right after the name of the index when the alter index command includes other options. You can recreate the index by online too. So this is also possible without applying a block to the table. So we can do the recreation process. Recreating an index, when you are going to do it in online, create index name, and on after that on key and close, and the table name, and within the bracket you are going to represent a column name. The only word online is added at the end of the particular query. Then index is changed. Alter index and the index name, rebuild online. So this is also possible. Again index is changed. So create index is again you are going to create it, and rebuild is also possible with the help of the alter index command. So we are able to obtain information related to that index. So with the help of the user indexes view of the data dictionary, we can obtain information about the index of each user. So this is how we are going to list how many indexes we have so far created for a particular table or a tables which is in our login. So eliminating an index. So eliminating index is you are going to delete the particular index. An index should be kept active only when it is being used effectively. Indexes is not used frequently because the only drawback about indexes take more memory space and it reduce performance of the system, and occupies unnecessary disk space. So this is about indexes. The indexes can become fragmented, that is either deleted and recreated later. The command is responsible, the following command is responsible for dropping the particular index. So drop index and index name is represented. So this is how we are going to eliminate a index, but it must belong to our schema. To eliminating an index is possible. So we must eliminate or disable the constraint itself. So we are going to drop index and index name is represented, and drop index name is enough to eliminate a particular index. So the index is successfully eliminated or deleted. So next we can able to get the information related to that index, that is index name, for which table the index is created, and how much unique the table will be given by you, either it is unique or non-unique, and initial and maximum transaction, everything is represented here. So I thank you for listening the class. This is the information about index. So when you have a time, you can do it practically, so to make a better understanding related to that index. Thank you once again.